All right, in this next unit, Unit 4, we're going to be looking at the periodic table a little more in depth than we have previously and looking at some of the information that we can get from the periodic table besides what we've already found, which are the electron configurations. So to begin, we're going to go way back and look at the development of the periodic table that we know of today. So the first real kind of list of all the elements that were known came in the 1700s with a man named Antoine Lavoisier, and he basically took all of the 33 elements that were known at the time and he put them in a table divided up by the type. So he said there were gases, there were metals, there were nonmetals, and there were earths, whatever that particular term meant at the time. So that was really the beginning of developing a periodic table. And then after that, in the 1800s, a lot more elements were starting to be discovered because of the invention of electricity. So by the year 1870, there were over 60 known elements up from just the 33 that were known to Lavoisier. So the next person to really put together an idea about the periodic table was a man named John Newlands, and he proposed that you arrange the elements by increasing atomic mass. And when he did that, he found that the properties repeated every eighth element. So he was starting to see some sort of pattern developing when the elements were put in order by increasing atomic mass. So he was the first person to really start to see the pattern that we know of today when the elements are put in order. So then that led to the next two guys who were Meyer and Mendeleev. They both saw a connection between atomic mass and the properties of the elements. Now we'll see in just a minute, Mendeleev is really the one that's credited with the discovery of the periodic table because he actually was able to predict where elements will be once they were discovered, and he was very accurate in that. And then after Meyer and Mendeleev, a man named Henry Moseley changed it up slightly. He rearranged the table by increasing atomic number rather than mass, which is almost the same. There are a few slight exceptions to the order. And basically, he came up with a very clear periodic pattern. And we call that periodic repetition of the chemical and physical properties of the elements when they are arranged by increasing atomic number. We call that periodic law. And there are a lot of things we can tell about the elements based on where they are on the periodic table and how they are arranged and what other elements they're near. So we're going to be looking a lot at the periodic law. Okay, so all of that is summarized. So you can see starting with John Newlands and then Meyer and Mendeleev, with Mendeleev predicting the existence and properties of undiscovered elements, and then ending with Moseley, and he's the one that really put together the periodic table that we see today with all of the elements that had been discovered at the time. Okay, so now let's take a look at the modern periodic table. A lot of this stuff you might already know. We're going to make sure we go over it again. I included a blank periodic table at the very end of your notes. So if you want to get it out and you can, label everything and write all over it, if you want to look at your current periodic table and make sure you have everything labeled correctly, either of those would be appropriate for what we're going to do in the next few slides. So on the modern periodic table, we called the columns groups, we called the rows periods, and then elements in groups 1 and 2, and then skip over 13 through 18. So basically that's all of them but the transition metals. We call those representative elements because they kind of represent a wide variety of properties. And then elements in groups 3 through 12 are known as the transition metals. And then again, to go over what we probably, hopefully already know, elements are classified as metals, nonmetals, and metalloids. And remember, those metalloids are right along that stair step. Group 1 are the alkali metals, except for hydrogen. Group 2 are the alkaline earth metals. The transition metals are in the middle. The inner transition metals are the ones down at the bottom, and those are divided up into the lanthanide series and the actinide series. And then over on the right side, we have the nonmetals. Group 17 are halogens, group 18 are noble gases, and then the metalloids, again, are along the stair step, and they have properties of both metals and nonmetals. So they really represent that transition from the metals on the left of the table to the nonmetals on the right of the table. So as we can see here, we have our numbers 1 all the way across to 18. So groups 1 and 2, and then 13 through 18, those are our representative elements. Group 3 through 12, transition metals, inner transition metals down here at the bottom. You can see all the blue ones, those are the metals. The green are the metalloids, the yellow are the nonmetals. And then we have, it shows some of the recently observed ones, some of the brand new elements. Okay,